Hello friends, welcome back to the channel. It's been a while and some updates. I find myself being more curious to learn to pick up Solidity, and I've been taking this course from Cypher Updraft by Patrick Collins. For quite a few times now. It's always the same case of picking it up and then dropping it halfway. But this time I started to do a little practice, and I think what better way to hold myself accountable than to make a video sharing what I've learned so far. And so I'm going to start a new series talking about what I've learned in Solidity. Okay, cool. Cypher Updraft has a lot of courses, so definitely check them out. But I will be sharing what I came up with. It's like a very simple contract, and then just walking through what these things mean, and basically what I've learned so far. So we are on the Remix IDE, and I think all of the beginner courses will tell you to use Remix as well as your compiler or as your IDE. And so I'm on Remix, and so I have this idea of creating a contract where people can create and join these clubs, or like these clubs, and once you're in a club, you can sort of post your GM daily on chain. So it's a matter of like seeing which clubs have the most members, which has the most active members who can post GM daily. So that's what I had in mind, and I first wrote down here something like my goals. So I wanted a way to create clubs, a way to join clubs, and a way to GM online. Okay, so that's what I started off with. Let me just, can I make this bigger? No? Oh, seems like I can't. Oh, there you go. Okay, cool. So we've got a few things over here. On the left side is you can compile, you can deploy, right, things like that. I'm just gonna leave it closed for now. So I was told that the contracts always start with like this license thing. So SPDX license identifier MIT. If you don't, I don't memorize this. If you can just type, SPDX. Usually the autocomplete even, as I say that, it's failing on me. But something like this, right? Whatever. But usually the autocomplete sort of helps you with this. Essentially, it just means anyone is free to use this contract. Maybe, I don't know. And then we have Pragma, Solidity, and then the version number. Pragma just means I want to use this version of Solidity, and this thing over here, this symbol, just means anything above this version is good, right? And then followed by a semicolon to sort of finish your sentence. Also, just a disclaimer before I continue. There are things that might not be right in the way I explain it. I just explain it the way I understand it, and in that same line, I might miss out on a lot of important information that could be useful in helping you to understand. But I'm just gonna continue. Okay, so the first thing we want to do is, so this is the file name, like membership.sol, and then I want to, you first want to say contract, right? So what's your contract name? I call it membership, and then encase everything in this curly bracket. So you can see I just type contract, membership, and then curly bracket, and then it ends with this curly bracket at the end over here. So this is my membership contract. Okay, And in a contract, you can do several things. You can declare variables, like this one over here. This is club ID is a variable, and I'm declaring the variable. You can write your function. So what are all the functions that are available in your contract? You can also write events. So what are all the events that are emitted in your contract? Okay. So with this in mind, I have these 3 goals, right? I want to create a club, I want to be able to join a club, and I want to GM online. So first thing is I went straight into function. So ignoring all this event, right? I didn't have all this. This is added in much later. First, I went straight into creating a create club function. So function, create club. The format always follows where you tell it function and then the name of your function, and then in parentheses would be your input. Now, if you've worked with EVM data before, especially traces, this part over here in the parentheses is the input data, or I should say are the variables in the input data, right? In this case, there's only one input, which is name, right? And this name is of type string. I don't have any functions here with an output, but if there is a function with output, you would see something like returns, I believe, and then you would have the same thing, right? It could be an address, right? It could be uint, right? But returns here would mean there will be an output, and in your EVM traces data, you would see an output. If there is no returns, there will not be any outputs, and instead there will only be inputs. So function create club, and then parentheses. First is the data type. So data type can be uint, int, string, address. Those are the main ones, right? And then followed by the visibility, I would say. I don't know what's the exact term, but for example, uint, in here I'm declaring a variable called club ID, right? So uint is my data type, and then club ID is the variable name. But I didn't write the visibility here because all data types have an innate visibility. So in this case, I think for uint, it is internal, which means only the contract can access, can read this information, this club ID variable. Totally fine to spell it out, but if not, if you just leave it, if you just omit it, I saw private of that, but if you just omit it, Solidity will use the default of that data type. So in this case, I have not gotten into why string uses memory yet, but from the tutorial, they say just use string memory, so I'm just copying string memory. And then your input name, which is name, right? Underscore name. Now this underscore name always confuses me, and it is because, and I had to go to, got this from ChatGPT. Essentially, you can name it anything you want. It's just that people use this underscore convention so that it differentiates between what the user inputs and what the actual variable name is. So in this case, spoiler, you can see there's a name here, right? And so you don't want to, when you're using this versus this, you don't want to make the code confusing, I guess. And so for convention's sake, I think people just use the underscore prefix. So string memory name, string data type, name is the name of the input. So when users, so you can imagine on the front end, when users go to this protocol website, there's a button that says create club, and when they click on the create club, for users to be able to create club, they first need to input a name. So that's how you think about how this relates back to your front end. Okay, so users need to input a name, and there will be a create club button. So with the name, the users can now call the create club function on this contract. Okay, so that's your sort of telling you what the input is. And then again, there's some visibility. Public here just means Solidity will create a getter function or a view function on your create club. In this case, because this is a function, and then public here would mean that anyone, other contracts, other people can click on this create club button. That's how I would think about it. There are other things here, I think, like pure, I'm not sure if that's right, internal, and then there's like external, but I'm just going to use public because I want other people to be able to click on this create club button. And then if there are no outputs, you don't have to add in returns, right? And then you would add a curly bracket, and so your function of the create club now is within the parameters of this curly bracket. Right, everything in every content here, all the content in here relates to the create club function. And so what is needed to create a club? Well, I've got an input for a name. How can I make something from a name? So that's where this struct comes into play, and also this club ID variable come into play. So struct is a data type, and just like uin, right, it's a data type. But why is struct kind of unique is because struct is like a collection of different variables that you group together, and you can add things like, you can say, in this case, struct club, and this club is a collection of the owner address and the name of the club. Okay, and this is how we will define it. We will define it as the data type and then the variable name, data type, variable name, right? So this whole thing is a collection of data, which I'm calling club, and this struct club contains the owner address and the name of the club. Okay, as compared to this club ID, which is just a unsigned integer, and I'm saying let this be 1, right? Give it a value of 1 starting value. Another thing I learned is that all these data types have a default starting value. So if I just say uin club, right, this works because when Solidity compiles, Solidity would add in equals to 0, right? uin 256 default value is 0. Address, the data type address, its default value is address 0, which is the 0x and a bunch of zeros. And then string, I have no idea. Maybe it is null, right? I have no idea. But yeah, I know uin, I know address, and then we'll see how. So I created a struct called club, and a club is a collection of data containing information about the owner, address, and also the name of the club. So let's go back to our function, and then we see this syntax here, which seems quite complicated. I got confused at first as well. I thought this is an array. It is not, because you will know that clubs is, oh yeah, I need to introduce mapping as well, but let me just explain. This is not an array because I guess you need to know what clubs is first. But yeah, spoiler alert, this is a mapping. This is the syntax to be able to put something in the mapping. So let's talk about mapping first. So mapping is another way to declare things. So just like how you have static ones, like club ID is one, struct club contains this information, you can also map things onto things. So in this case, let's say I have some information, right? Let's say this club has this owner and this name, but I want to give it a number so that I can easily identify that particular club. And so to do that, I use the mapping. And so I would say u56 map onto the club. Now I'm curious why is it club and not struct? I mean, I guess this works. But yeah, that's the whole point of doing this, which is putting a number to a club. So now I can say club 1 refers to this particular club, club 2 refers to another club, so on and so forth. And because this mapping thing is a variable as well, you also need to have the visibility. In this case, I say it to be public, and then call it a name and give it a name called clubs. So clubs is a mapping of number to a specific club, capital C. Okay, I think we can continue from that. So clubs, we can always refer back to what we've declared and see what we have, right? So clubs is referring to the mapping that maps from a number to a specific club. Now, first let's look at the right hand side of the declaration, right? Club with a capital C is my struct, which is owner and name, and this is how you would put things in the mapping. You would say, because this is a struct, you would have this syntax, but if it's not, if your mapping is a uint to an address, this would just be an address, right? But because this is struct, we have this special club and then what are the inputs. So our club struct is owner address and also the name. And in Solidity, you can use message or MSG, message.sender, which would be the address that initially initialized the transaction or started the transaction, initiated the transaction. And so this would be the owner address, because this owner is the address that click on the create club. So I'm getting the owner address and also underscore name, which is the input that the person gave when they click on create club, right? And put it all together in this struct, add the mapping, add that to the first mapping of clubs with an S. So what is club ID though? I don't see any club ID here. Well, you might recall we've already declared club ID right in the beginning, and because it's declared outside of the function but it's still in the contract, this variable is usable for everything within this contract. So I now have uint club ID 1, and because I declare as 1, here will be 1. So you can imagine clubs 1, and what's my mapping? I'm mapping from a number to the struct. So this whole line is saying, map the number 1 to a struct club with message sender and whatever name that they just inputted. Okay, this is just a syntax, you just need to know this, right? Clubs bracket club ID, which is in this case 1, and equals to what is a struct, right? Because this is what we use in our mapping. Okay, now that we've sort of mapped that into our mapping called clubs, now I want to I want to be able to say what are the list of club IDs out there, right? And to do that, I first need to declare an array called club IDs, right? So it's an array of, well, club IDs. And the way you would define array is you would first have the regular data type, like uint256, and then you would have these brackets. This would mean it is a dynamic array. If there's like a number inside, this means it is a fixed array or static array. I think fixed array, which means it can only hold 2. But without it, it is a dynamic array, so it can hold, infinite amount of club IDs. And as usual, public, anyone can see this, anyone can read this on the contract. And then club IDs, calling this club IDs. So now we have the mapping, right? The next step is, say, because the number 1 is already used to map to this struct, I'm going to store that number, right? I'm going to keep it into my collection of club IDs. And what this is doing is pushing the number, in this case 1, because it's the first instance, into club IDs. Okay, this is the syntax of adding elements into the array, right? The array name dot push and then whatever number there is. Again, this is syntax. If you don't remember it at first go, the more you do it, the more you ask AI, the more you would remember it. And then our last step is, of course, to add 1 to the club ID, because 1 is already used for the first initial create club, right? That I want the next instance of club creation to have 1 plus 1, right? 2. And the cycle continues, right? Now that club ID is 2, the next time a person creates a club, it will be mapping the number 2 to the struct club. And then club IDs would push the number 2, store it in its array, and finally we increment the club ID number again. So create club now works, right? Anyone that puts a name can now create club, and the next time someone tries to create a club, the club ID is now properly handled. In Remix, there is a cool function to compile here, so you can just click, you can select the contract you want and just click compile. Blah blah blah, this is wrong, so it's telling me my license thing is wrong. Do I need this? Okay, there you go. So yeah, this is the license thing. Successfully compiled. Now we can deploy it on this VM, Remix VM. So deploy, and we would see a few things. One, let me just expand this. Oops. Okay, we see. Imagine this like Etherscan, right? So we see the transactions here. This is successful. We successfully deployed on this VM. This is the bytecode and some constructor stuff. And now we can click on our deploy contract and we can interact with the contract. So we've only covered create club, so I'm gonna only interact with the create club function. So, and one more thing I forgot, all these functions here are exactly the functions you would see on Etherscan when you look at the read or write contract tabs, right? In this case, our create club would be under the write contract tab. So something like, transfer from, imagine this is create club, then input your name, right? Input the name of the club you want to create. So let's go ahead and say first club. And if I hit create club, you will see there is a transaction after this that comes up here. So there you go. So you can see in this transaction, it succeeded, and you can see the events because I I emitted an event. I didn't cover that, but maybe in the next video. And in the what's this, 2 number first club, interesting. Yeah, I don't know what's this, but this is the owner address, and this is the name, right? So first club, there you go. So now I can say what is the club, what's this club, input required, really? Club IDs, let's go 1. Oh, I think club IDs shouldn't be, I don't think club IDs should be public because there's nothing I can do about it. Okay, I mean, yeah, we created a club, and we can also look at, I think, the mapping, right? So if I put 1 here on club, yeah, there you go, we see, because this is a mapping of number to the club struct, and we inputted a number which is 1, which is our club ID, and it gave us back the club struct, which has the owner address and name, and this is exactly what we see here, owner address and the name, first club. There you go. Yeah, I think, yeah, I mean, there's a lot more, there's like 3 more functions, but I think that will be it for the first video of the series. Hope you enjoy it, and yeah, I'll be making more videos talking about what I've learned so far. Let me know in the comments if you like this, and thank you for watching, and I'll see you in the next one. Bye.